let's run the first part. And when we run the first part, the result is 129.29. Because when we pass 0, so here, take is now 0, and make is now 29, right? And when cake is 0, we're going to add 1 to the cake. So now cake becomes 1 here. And we want to print out cake. So that appears here. And when cake is 1, we want to print out make. That is 29. And then we pass this else statement because we satisfy the condition here. So we are going to return make. And the result of running this part is 29. Then it will print out 29 once more. So the result is 29. All right. And what is the result of running the second expression? In this case, cake is 1. All right. So cake is 1. So this part is skipped. And we pass to this part. And cake is 1. So we are going to print out make. So that is mashed potatoes. And we are going to skip this part because this part is satisfied. So we are going to return make, which is mashed potatoes. And it is going to print out mashed potatoes. So the total result is 129.29 mashed potatoes and mashed potatoes, right? And I would like to mention one more thing about functions. When you design functions, we generally want our functions to do a single job. I'll talk about what this means with this example. Let's say if you want to check out if two strings have the same value, or two numbers have the same values, same length. So for example, this is going to be true because they have two lengths. And this will return false because the length of this one is 3 and the length of this one is 2. So this is what we want to implement. So what we can do is a digits equals 0, while a is larger than 0. What we are going to do is count the number of the digits of the first one. And we can do the same thing, b digits. And we're going to return if these two digits have the same length, like this. However, when you look at this implementation, these two parts have the same look, appearance. In that case, what we can do is define another function like num_digits. This one receives a number. So we can make this part as another function like num_digits. All right. And what I'm going to do is So rather than implementing this function as this one, we're going to remove or turn this repeating part as another function like this, and we'll delete this part like this, okay? Then the implementation becomes simpler and clearer, all right? And much easier to understand. So functions generally do a single job. So that's what I meant by this. So I'll leave this part. All right, so that was about functions. And there are some special default functions provided by Python that is called maps. Reduce. I'll just briefly introduce these three functions. They are not that difficult. I'll just introduce map first, and then you can have a look at the references of filter and reduce, all right? Let's say we have some names of our pets. So Alfred, Tabitha, William, Paula, all right? And we want to make these names capitalized. So when you want to do that, what you can do is call this upper function or method as we did. So this is pretty similar to what we did for list comprehension, right? So all the names are capitalized. However, we can do this with list comprehension, but we can even further simplify the list comprehension by defining some other function like this. Let's say this third upper function receives a string and return capitalized string like this. All right. And what we can do is call this map function. So what it does is it maps this third upper function to each item inside this my pets list. So we are simplifying this part with this single line expression. So that is what basically map does. So map is mapping the given function star upper to each item inside this list. Okay, that is what map is about. All right. So that is what map is about. And I'll give you some other examples. I'll leave some other examples in this class collab after class, so you can have a look on that. So up to this point, are there any questions? Okay. And the last topic that I want to discuss today is higher order functions. So what are higher order functions? Up to this point, our functions could receive some other numbers or objects. However, higher order functions takes another functions as arguments or returns a function as its result. All right. So higher order functions receives functions as arguments or returns a function as its result. So why do we do this? Let's have a look at this one. Let's say we want to calculate the sum of just normal numbers and squared numbers and cubed numbers like this. And when we see these, they have the same computational structure, right? So what we can do is we are going to implement summing naturals with this sum natural function. And what we can do is total k is 0 and 1, while k is smaller than n. So this is what basically implements this summation function. All right. So what we are going to do is from 0 to n. So here n is 5. We're going to sum these numbers to total and return total. All right. And for squares, we can basically do the same thing. Right. However, rather than saving k, we're going to save k cubed, not squared. All right. And for cubes, we're going to cube these numbers. And they basically have the same structure, computation structure. And how can you simplify this implementation? We can do this, simplify this implementation by utilizing higher order functions. All right. So how can you generalize this computation process? Let's first define identity. And this one returns the same number it receives. And this square function return squared version of k. And this cube returns k cubed like this. And we can define summation like this. Basically, we do the same thing as the previous one. And what we are going to do is, while k is smaller than a, what we are going to do is so here, we can pass term, which is function here, and we can simplify this implementation using this summation function. All right. So what we are basically do is some squares, for some squares, what we are going to do is summation 5 and pass square like this. So this will basically do the same thing as the first implementation, sum naturals. So this implementation corresponds to this one, and this sum squares becomes, by passing square, you can get the same result. And for some cubes, you can just pass cube function. So this summation function receives two things. The first parameter is just number, n here. And the second parameter is another function, how you are going to modify these numbers here. Okay, so by using higher order functions, you can simplify some implementations like this. And this, so I told you that higher order functions takes another function as arguments or returns a function as its result. So this one is the example of a higher order function that takes another function as arguments. And I'm going to show you another example that returns functions as its return value. Let's say we want to define a function like this. And this one is a make-adder function. So this one returns a function rather than just a simple number. So to do that, we are going to define another function inside this function body. And this function returns an adder that adds n to the given number k. All right? And we are going to return this adder. And what we can do is so what is the type of this adder example? That is a function. So this one basically returns a function adder like this. So we can pass some numbers to this adder. Let's say we pass 6, and it's going to add 3 to this number. So that is what this make adder is doing. All right. All right, so time is up, but I still need to cover some other materials. So I'll just keep on, and if you have to leave, you can freely leave, and I will upload this video on the YouTube so you can check it. But still, I will keep on explaining other functions, other materials. So up to this point, we've discussed higher order functions. Higher order functions can receive functions as parameters like this, or return another function as its return value. All right. And the last thing I would like to discuss is lambda functions. So lambda functions are also very useful functionalities of Python. This one is to simplify the process of defining functions. All right. So let's have a look at this one. These functions are very simple. And it's somewhat cumbersome to use this def keyword and return keyword. But using lambda functions, you can simplify this process. All right. So, for example, to simplify defining this square function, you can use lambda functions in this way. For defining a lambda function, you use this lambda keyword. And this one indicates the parameter. And after this column, you indicate what you want to return. So these two are going to do the same thing. One caution is that you should not use return keyword here. Okay, so this one is not correct. So when we define square like this, we can square numbers. Using this square function. And for defining cube with lambda function, you just indicate lambda keyword here and indicate the parameters and just indicate the return value like this. Okay? So this is pretty simple. And lambda functions can receive more than one pair of parameters. So for example, let's say we have these two lists, my strings and my numbers. And you can combine the map function we discussed previously. And for map function, you need to pass a function here. However, if this function is very simple, you can just pass lambda here, x and y. So this one receives two parameters, x and y, and returns this tuple. And you are going to pass two lists like this. And this will create a list of tuples combining the values in the first and second lists like this. So for map, you pass this function, right? So this function is cumbersome to define. This one, right? So this simplifies some function implementation like this. Okay. And for this, you can also change this one as, rather than defining identity function, we can just pass lambda like this. Okay. So these two lines implement the same thing. All right. And you can use different names like K and K like this. You just need to be consistent. If you use Y here, it has to be Y. Okay, if you use P here, it has to be P. So if you are just consistent, whatever you use for the name of parameters doesn't matter. Okay. All right, so this was about lambda functions and higher order functions. So today we talked about containers, sets, and how we define functions and some map default function and higher order functions and lambda functions.